Hi, everybody. Welcome back to, well, we're going to call it Chapter 6. That's really what it is in the textbook, but for us, it's really Chapter 5. So you call it what you want. I'm going to use the numbering Chapter 6 from this point forward. Hope that's not too confusing. Now, for those of you who are familiar with my work, I tend to work at a smart board, and you may notice that in the bottom right-hand corner, it says 1 out of 24 slides. Don't get scared. Usually I only have about 4 or 5 slides. In this case, I've done something different. Rather than breaking it down into individual lessons, I have one giant lesson because how I normally deliver this is a little complicated and can be a pain for me to follow along with. So one file where everything was put together made the most sense to me. So it's got nothing to do with nothing for you guys. Today we're going to spend a little bit of time just simply reviewing what we've already looked at in chapter, I believe I called it chapter 2. Yes, it was chapter 2 for us. But we kind of diverged to go off into polynomials and get into algebra because this unit is going to require some of those algebra skills. So without further ado, let's do a little review. So we're looking at linear equations. And the main formula for that is y equals mx plus b. Now, the reason I call it the main formula is there is one exception to y equals mx plus b, and we will review that shortly. I don't believe it's today. I think it's tomorrow, and it is. Looking ahead. Oh, wait, no, it is today. Hey, aren't you lucky? But first, we're going to do a little bit of review of what all these things mean. So y equals mx plus b. The y is your dependent variable. And the reason it's called that is it depends on everything on the other side of the equal sign, right? Those things change and tell us what y equals. M is the rate of change. Now, for us, when we were working in the class, we had that little chart that had a gazillion things on there. And if I remember, I will put it at the end of this lesson just so you have the reminder of where all the rate of change comes from. But between today and tomorrow, we're going to cover all of them anyways. You know what? I think I'll do it at the end of tomorrow's lesson if I remember. Usually, we call it slope. X is our independent variable. And although there's a whole lot of variables in here, you got to remember that when we fill this in, y and x stay, m will be a number, b will be a number. Speaking of b, it is our starting value. Or it's considered our y-intercept. Now, more on that in a little bit. Now, we have something that's called a unit rate. And what this is the change in one thing, one unit, relative to the change of a second one. And that's kind of a vague definition for something that we actually deal with all the time and we're very familiar and comfortable with. So probably the most common example that you guys have seen in everyday life is speed. Speed is a comparison of kilometers to hours. Okay? And that's one that we deal with in our everyday life all the time. Cost is another one. We might not think of it as a unit rate, but whenever we go into a store and say, hey, look, there's a can of Coke for $1.50 a can, that's a unit rate. We're so used to think of it as $1.50 a can that we don't really think of it in terms of its mathematical terminology, because why would we? We're normal human beings, at least most of us are, and we don't think that way. Sometimes we have to develop what the unit rate is. Sometimes we're given what the overall values are and we have to figure it out in the end. So for example, my water flow example, number 3, if 50 liters of water is used up in 10 minutes, it means that we're using up 5 liters per minute. Generally speaking, the key word we're looking for is per. If you hear the word per, kilometers per hour, $1.50 per can, 5 liters per minute, that means you're dealing with the unit rate. We're going to get a little bit more fancy schmancy off the graph, and we're going to try and figure out what the slope is. Now, we're going to bounce back and forth a little bit. So step 1. So the first thing is we're going to choose 2 points that are on the line, and they should be on the grid line. That is going to be best. And it doesn't matter which point. Choose any 2 points, and it shouldn't matter. So just to be difficult, I'm going to pick this point here and this point here. Okay? Because they're in the middle of the line. I also could have chosen, I suppose I could have chosen the one at the end. Actually, 2, 4, no. Sure, let's go with that. Step 2. If you were in my class, then I taught you to draw a triangle. That's right, I said tringle. For those who have forgotten and miss it, I don't like calling them triangles. Now, not a mandatory rule, but it's a good idea to use arrows to go from the left. Well, to go from the left point. I'll spell point correctly. Okay, so, oh, there's somebody emailing me. So if we're starting at the left one, hopefully you know which side left is. We're going to draw an arrow this way. Hopefully you can draw a line straighter than I am. And we're going to go this way, right? We're following the path laid out by the grid marks. And remember, right is positive and up is positive. So in this case, both of my values are positive. Pay attention to your scale. Oh, that's actually my very next point. 1, 2, 3. We're going up. 1, 2, 3, 4. So we've counted. I suppose I should really specify that it's a +4 and a +3, and then ask you to realize that what I called a 4 was actually a 3, and what I called a 3 was actually a 4, and just love technology sometimes, and just accept that that's the way it is. Okay. Now, what you just watched me do, or is counting it, is measure the lengths. Measure using the scale. The rise, delta y, and run. Okay, so up here, this would be delta x, not ax, delta x, and this would be delta y. Finally, I'm going to squish it in here, calculate slope. And for those who don't remember, that gosh darn m equals rise over run, or or delta y over delta x. Yay for deltas. So let's calculate m over here. My rise is 4, my run is 3, and in this case, that's all I have to do. My slope is 4/3. Now, the disadvantage to using a graph is, did this point really go through the grid lines, or is it this point up here? Unfortunately, that's a bit of a judgment call. When I'm marking your tests or assignments, you're going to get a bit of leeway in this. All right, give the one on the right a try. All right, 1, 2, 3, 4, 5, 6, 7, 8, -8, negative, and that's a 2. So m equals -8 over 2 or -4. Oh, and there you go. That's it for today. Hopefully that's enough that you can sort life out and make sense of things. Like I said, this should be review. The one thing that you do have to remember is put your fractions in the lowest terms. Alrighty. Well, good luck, guys.